We're going to be talking about SUSE Storage Solutions today. My name is Mike Dilio. I'm the Product Marketing Manager for SUSE Enterprise Storage, and joining me is Sanjit Singh, who's the Director of Solutions for Storage here at SUSE. So we're going to tag team a little bit, and just to start off, we've just got a basic agenda. I'm going to talk a little bit about the market, business challenges, talk a little bit about SUSE Enterprise Storage, some of the things that are going on currently, make some recommendations on other sessions that you all really need to go see while you're here, because we're going to be coming out with a new release of SUSE Enterprise Storage later on early this summer. And then I'm going to turn it over to Sanjit to go in depth on the solutions that we currently have and some of the things that we are looking for moving forward. So to start off with, you probably all know this. You're probably all experiencing it either with your customers. If you're a partner, you're seeing it with your customers, or if you're one of our customers in your own environment. There's a data explosion going on. There is a tremendous amount of data being generated from not only the traditional sources, databases and other information, but from unstructured data. And that's where we're seeing this tremendous growth. So at the heart of that graphic is IDC's revised numbers for data growth. So they're predicting by 2025, we're going to be looking at 175 zettabytes of data. That's 10 times what we are seeing today. And again, a lot of it is from these unstructured sources. So email, yeah, always going to be a lot of email. But from a video standpoint, we're seeing it in media and entertainment from rendering. A lot of movies, a lot of CGI that's going on, and a lot of the new movies that are coming out. So tremendous amount of data is being generated there. Also, law enforcement. Here in the US and around the world, law enforcement officers are wearing body cams. All that data has to be stored. It may be used in a case, it may not, but it's going to have to be archived. Medical data, I just had an MRI Saturday. That's stored somewhere in the cloud now with my doctor. CAT scans, X-ray, patient data. Mobile data, everybody's got a mobile phone. Where's your data being stored? And how much do you have? I'm sure you're running out of space, so you're putting it up in the cloud. We just did a survey, a Google survey over in Europe, and asked some simple questions about mobile data, and a lot of people, they didn't care where it was. Some wanted to know where it was important to them. It was very interesting. It was just a short set of questions, but we got such varying answers on it. We're going to continue to do it and see how that looks worldwide. IoT, sensors. There are sensors on everything. Example I like to use was an article I read about Airbus. Their A350 aircraft has 6,000 sensors on one airplane, and it generates 2.5 petabytes of data a day. That's just one plane. The A380, the big, gigantic plane that they have, has 10,000 sensors in each wing. And it's just an extraordinary amount of data is being generated by these sensors. And it's not just aerospace, it's across all industries where we're seeing sensors being used. And then transactional data. So this is not going away, and we're seeing our customers and our prospects and our partners looking for different ways on how do we address this exploding data. So there are limiting factors with legacy or traditional storage systems that we run into, or that you run into. They are difficult to scale and manage and to grow. If you are using a traditional storage system of controllers and disk arrays, and you run out of space, you put up another rack. Well, that's more power, that's more cooling, and it's very expensive, and it's not really efficient. If you can afford to do that, great. Unfortunately, as we all know, one of the mitigating factors is flat to lowering IT budgets. So other ways have to be addressed. I talked about the expense, and then the other thing we're starting to see is there are companies that still run legacy applications that need to remain, so they're going to stay on traditional storage. So those systems need to survive. We don't know for how long. But they may not be able to transition. If you're doing a digital transformation, they may not be able to transition over to a software-defined data center. So how do we address these factors? Here at SUSE, we call it SUSE Enterprise Storage. So it is an intelligent software-defined storage solution powered by Ceph technology, and it enables IT to transform their enterprise storage infrastructure into a way to deliver a highly scalable and resilient environment with no points of failure. So it's unlimited scalability. It is a distributed storage system, scale out, thousands of nodes, very simple to add storage to, and very efficient. It reduces your IT costs in a couple of different ways. I address it here talking about commodity off-the-shelf hardware, white boxes. Doesn't have to be a name brand. If you prefer a name brand or you work with a vendor of your choice is fine. But you can reduce the costs immediately. We've seen up to 50% CapEx cost reduction by using the white boxes, if you will. The other way is through a single management interface. I'll talk a little bit more about that. Just from an OpEx standpoint, somewhere up to a 30% reduction, and you don't need to grow your IT staff because it's easier to manage. That's one of the things that we're really focusing on is ease of management. And then the other is seamlessly adapt to changing demands, whether it's your business or just the data in general, talking about the data explosion again. It's very easy to upgrade and manage the system. As I mentioned, if you're running out of space or you're going to put up a new workload, you add another node, and you just keep doing that, and the system will rebalance itself with the new nodes that you put on board. Current release is 5.5. We released this in October of 2018, and I don't have all of the features listed here. It's quite a number of features, but some of the things that we focused on was performance, security, and stability. By coming out with a version of AppArmor and BlueStore, a new version of BlueStore, we were able to increase performance and stability and add security. Easier to manage, and I will talk a little bit more about that on the next slide, but there's been a lot, and the gentleman who works on it is sitting right here in the second row. Done a lot with OpenATtic and DeepSea, and we released the next iteration in October, and I'll talk a little bit more about what's happening and what will be part of the new release coming out in a few months. OpenATtic now has a tighter integration with SUSE OpenStack Cloud. So SUSE Enterprise Storage in general, we're really starting to move towards the cloud and containerization with this solution. So its capabilities are growing, and you'll see that with SUSE Enterprise Storage 6 and 7. And then expanded heterogeneous support, Ceph Samba, and support for non-Ceph RBD and Ceph FS clients. If you're interested in the roadmap, there was a session this morning, but Thursday, there's, you see up there in the right-hand corner, BOV1443. That's the roadmap session that we'll be talking about SUSE Enterprise 6 and other things that are coming. That's Larry Morris and Lars Marowski-Bree, our product manager and the lead architect. So check it. If you're not signed up for it already or you missed this morning, I'd definitely go see their presentation Thursday morning. So focusing on management, and we put a lot behind that. What I'm showing here is the OpenATtic interface. So this is the GUI that's currently running on SUSE Enterprise Storage 5.5. And it uses Grafana and Prometheus, two other upstream open source projects, to collect the data and create a graphical representation. Is what you see here on the right is the main screen. And you can customize that. So what you're looking at is what are known as widgets. So it's different pieces or different functions of the cluster in a graphical display, and if you select one of those, you'll get an exploded view of it. So in this case, we're looking at the pools. So this current release was taken and moved upstream and is now being worked on. We have engineers, SUSE engineers working on this, and also community engineers, about 20 engineers working on this, and it's now being called the Ceph dashboard. So it will be the default management interface for Ceph moving forward. And if you're interested, Len Grimmer, who's sitting here in the second row, he presented the Ceph dashboard this morning, and he has another session Friday morning. So if you haven't signed up for it and you're still here, because I know probably some folks will be leaving on Thursday, I highly recommend you taking a look at it, because the advancements that have been made in the short period of time from October last year until now are tremendous. And when you get down to the technology showcase, it's Kiosk 13, SUSE Enterprise Storage. They're running and demonstrating not only 5.5, but also 6.0. So please, when you get down there tonight or sometime during the week, stop by. There's plenty of SUSE experts down there that answer questions for you and help you out, help you understand not only this, but SUSE Enterprise Storage in general. So just a quick look at the reference architecture for Ceph and for SUSE Enterprise Storage. So at the heart of it is Rados, which is the common object store. All data that's brought into a cluster, a SUSE Enterprise Storage cluster, is stored as objects. But we do support object, file, and block. So it is a truly unified system. And we support the three types of storage through gateways. So for block devices, we use iSCSI for object store, S3 or Swift, and for file store, we use CephFS. So the system is a collection of servers. The OSDs are where the data is actually stored. The monitor servers are what keep an eye on what's happening within the cluster. The gateway servers are how we do the interchange between the different storage types, and there's also an admin or a management node that's included. And this is what scales horizontally, or the OSDs, that gives us the ability to continually grow and have unlimited scalability. Mentioned earlier about legacy and the fact that some people can't just jump off of legacy storage right now because of applications they need to continue to support. So we do keep the traditional in mind. So we have support for NFS in both file and S3 objects, NFS for S3, so we can move that data up to an S3 repository. SES6, we also have some new features that are coming out, so that's why I keep recommending the roadmap session. SMB CIFS for Microsoft Client, and iSCSI, we were the first to bring iSCSI to market, and it's made a big difference in the block storage arena for us. Native protocols, Rados block device for block, Rados, the common object store I mentioned in the previous slide, CephFS, and S3 and Swift. From a hardware perspective, x86 servers, and now we're starting to see a lot more interest in ARM. And one of our guys is he's been testing ARM servers out in our lab in Provo. We've got a prospect who's looking at, from an edge standpoint, deploying 5,000 nodes of ARM servers. Simple reason, it's cost effective. They don't need the horsepower, it's only one processor, and they get, they're less expensive than the x86 with dual processors. Excuse me. And then deployment. There's several ways to deploy Ceph or SUSE Enterprise Storage. You can roll your own. You can do it yourself, again, with the off-the-shelf commodity boxes. We have the documentation and the configuration materials to help you along with that. So it requires your brain power to do it if you're into doing that kind of stuff. We have reference architectures. So we do partner with several of the IHVs, Dell, HPE, Lenovo, others, Supermicro. And we have a library of reference architectures that are step-by-step cookbooks, if you will. If you follow the directions, you can build a cluster based on their hardware and our SUSE Enterprise Managed Storage. And then we do have one vendor we're currently working with, Thomas Krenn out of Germany, that builds pre-made appliances. So some people, they just don't want to do anything. They just want to rack it and stack it, plug it in, power it on, it works, put my workloads on it, I'm done for the day. And we are talking to other vendors, other IHVs about the appliance model, because it is a very popular model. So I'm going to turn it over to Sanjeet, but before I do, I was wondering if anybody had any questions or any comments. All right. Well, I thank you for your time, and turn it over to Sanjeet.
Thank you.
Thanks, buddy.
Hi, everybody. My name is Sanjeet Singh, and I'm the Storage Solutions Director here at SUSE. So I'm going to spend a little bit of time talking about how our customers, your peers, and if you are a partner, your customers are deploying storage. What are the use cases? What are they doing with storage? About two and a half years ago, I joined SUSE, and we changed our go-to-market model to start focusing on use cases. And this is the result of that change in our plan and strategy. So for a second, Michael has already talked about some of the reference architectures and the appliances that we have. And that's pretty much available with all hardware partners. You can choose your own server, and we have reference architectures for those. If there is anything else that you need to add, we have a validation team that can very quickly do that. So we can take that custom build and eventually create a reference architecture also. But let's focus on those top and the bottom workloads that I really want to spend some time on. There are a variety of workloads which fit the SDS model really well. Backup, HPC storage, file sync and share. Those are some of our classical workloads, what Gartner would call mode 1 customer might be deploying it. SUSE Enterprise Storage is a very good fit for your traditional storage, traditional data center, but also fits very well in some of the mode 2 customers, as Gartner might call it. Mode 2 or software-defined data center or cloud-native workloads. Examples of those include SOC, SUSE OpenStack Cloud, or OpenStack generally speaking, containers. Data lakes for analytics use cases. And we'll get into that in quite some detail. I'll give you a specific customer example also. And then there are custom applications which are being written that require a large repository of data. The perfect example of that is Deutsche Telekom that created an online email system, a Hotmail-like system using SUSE Enterprise Storage. They presented at last SUSECON, which was about, I think, a year ago. They had a presentation talking about how they did, what were the challenges, how did they succeed in creating that. And they ended up using Ceph FS in conjunction with the custom application that they had for creating that online email solution for customers. OK, so let's talk about each of these workloads. Backup turns out to be one of those lower risk areas where customers want to try it at first. Whenever they introduce new technology, they tend to do it through backup. Many of our customers start with backup. They know that 40% of their enterprise capacity is probably locked into backups. And then over time, when they get experience, they start looking at other use cases also. So this turns out to be a very popular deployment model for our customers. We have all the major software partners certified. More are being added to the list on a regular basis. And if it so turns out that there is a requirement for somebody, we can go ahead and get that certification also. For example, Bear OS came in request to a particular customer based out of California that wanted to deploy Bear OS. And we worked with Bear OS to get certification for SUSE Enterprise Storage. Similarly, Veeam is another one with which we have spent quite a bit of time. They even have a booth downstairs, and they have a session talking about some of the reference architectures that the Veeam has created with us. So what's the benefit of SDS in a backup environment? Lower cost. The classic example there I give is there was a customer, this going back many years, that had a deduplication device with Commvault software. At that time, they had 200 terabytes. A couple of years later, so they planned it out for 3 years worth of data growth. But 2.5 years later, that 200 terabyte device ran out of space. They ended up pulling out an undepreciated piece of hardware from their environment, replacing it with a 400 terabyte dedupe appliance, thinking this is going to last at least 3 more years. Capacity growing faster than they can expect. 2 or so years later, they start hitting the upper limits of that device also. Then they pulled out that 400 terabytes and got a quote for 800 terabyte system. And that's when they realized, you know what? There is something wrong here. We can't continue doing this. And they ended up deploying a SES-based system, 800 terabyte system. Instead of 800 terabytes of a deduplication system, they ended up choosing a 1.2 petabyte SDS system, Ceph-based system. But the advantage that they got was, in case they under-forecasted their capacity growth, all they would have to do is add one more server and one more node, and the system would increase its scale. Yes, dedupe devices now have the ability to write to cloud and tear it off, but it still becomes that one bottleneck. The misforecasting of storage capacity ends up being a problem. And that's the advantage that they get with these scalable solutions available now. Improved SLAs because they can keep more and more storage. This particular customer eventually ended up, they were keeping a 30-day window online. They ended up with a 90-day window online. Scalability, we just touched upon, and meet regulatory requirements. And that's where, as requirements change, as newer requirements like GDPR come down the line, they can accommodate that because of the flexibility that software-defined storage offers. Specifically with Veeam, we have done a lot of work with Veeam to create specific reference architectures. Veeam can write to multiple tiers. So what some customers are able to do is put a high-performance tier in their local data center and, for example, have an archive tier or have a cloud tier, which is in a secondary data center. This allows them to keep another copy of their data in a separate location altogether. I'd encourage you to check out that session, which is being delivered, I think, tomorrow. They will go into much greater details talking about Veeam reference architectures. OpenStack Cloud. SES has been in the market for about 6+ years at this point. It was built for OpenStack when it initially came out. Soon we started adding other workloads, but this was the first workload that we supported. And we still have a large number of customers that deployed for OpenStack. Some of our largest clouds out there have deployed or tested Ceph with OpenStack. When SAP did its cloud platform about 1.5 years ago, they deployed a SES-based system underneath. That was one of their successful implementations that they did, which they announced about 1.5 years or so ago. We have a number of other customers that have deployed SES for OpenStack. Moving to HPC storage. HPC storage is one place where customers have a lot of affinity to open source. Often because of their comfort level with open source, often because they are in the environment where they have to push the boundaries of their entire stack, top to the bottom, on the compute side, on the storage side. So Ceph turns out to be a very good fit for many use cases within HPC. Primary storage is probably there's a big asterisk on top of that. Ceph doesn't have the low latency needed in most cases. So it's recommended in test dev type of environments for HPC storage as primary, or it would be for very small HPC deployments, say a couple of hundred nodes. You don't want to go much beyond that. As a nearline or archive storage, on the other hand, it's a very popular deployment. We have customers deploying this in a archival mode in many use cases, in many different forums, under many different applications. University of Maine is actually doing a session tomorrow talking about how they deployed Ceph for archival as well as home directory use case. Home directories, what customers can do is set up a Ceph-based system, give a Ceph FS-based system, give out directories to their grad students or to their professors, and data can be read in and out from those directories. And most of these customers have somewhat sophisticated data management policies, and they can sort of accommodate Ceph underneath an HPC environment. Ceph is certified with DMF, which is a data management software, as well as iRODS. Now, iRODS is not necessarily HPC only, but it does get used in HPC also. Let's talk a little bit about iRODS. iRODS is broader than just HPC. iRODS is truly a data management solution. What is iRODS? iRODS is a file virtualization product. It can basically consolidate a variety of storage architectures underneath it, and then automate the management of data within those storage tiers. It allows you to, for example, have a high-performance tier that's all SSDs running ingest only for, say, an AI workload. You write it over there, and then over time, tier it off to a second-tier storage solution like Ceph. Or it can even allow, if the performance requirement is not very high, Ceph directly can be the storage location for an incoming stream of data. What iRODS will do is consolidate everything in one single global namespace for you. And the other advantage that you get with iRODS is because of its sophisticated data policies that you can create using metadata, it can also allow you to search. It can allow you to create permissions and limit data from flowing from one data center to another data center, et cetera. It significantly reduces OpEx by consolidating various tiers of storage. And it can allow discovery to proceed in a much faster and a better manner, much more automated manner. With iRODS is already certified with Ceph. We, in fact, have a number of customers also. Most of them today using S3. And the native RBD connectivity between iRODS and Ceph is still in beta. And you'll be hearing more about that in a few months. By the way, if there are any questions or comments, please ask them away. It's a very quiet room, it seems. Questions for any of the previous few slides? Comments? Throw stones? Throw tomatoes? I hope you don't have any tomatoes. OK, let's talk containers a little bit also. Who's deployed containers out here, by the way? Anybody deploying containers? OK, 1, 2. Anybody testing with containers, not necessarily in production, but dev or, OK. Anybody else? All right. Containers are stateless. Why do you need storage, right? Yeah, that doesn't work anymore. You do need storage. Storage is everywhere. The stateless thing is gone. It was 2 years ago. So what Kubernetes and the CloudCon have, the foundations for supporting containers have done is they've started creating interfaces for storage. And recently CSI, the container storage interface, came out of beta and became supported officially. That's the connectivity from Kubernetes to Ceph. That allows you to create containers and connect them to a Ceph-based system. As of today, CSI only works with RBD, and CephFS was recently launched. So only with RBD and CephFS. But if you are looking or deploying containers, Ceph turns out to be a great solution, not only because of the scalability, but also because from a roadmap perspective, where Ceph is headed. In less than a year, Ceph will be fully containerized in the sense that you can have Kubernetes, Ceph running in Kubernetes managed by an orchestration layer called Rook. That way, you will have a truly hyper-converged solution with containers or your applications running on the same node that are all being managed by Kubernetes. As of today, we don't support Ceph on the same node as Kubernetes. It is available in the upstream as beta. SUSE does not support it yet. We are working on it. We are one of the top contributors to it. We expect to have it by sometime mid next year. If you want details, go to that storage roadmap session. Lars and Larry will be talking in much greater details about their plans for what they're doing with storage in containers. Analytics. I touched upon large capacities, and the backup is probably one of the larger capacities in enterprises. That's today's statement. Go out 3 years down the line, 5 years down the line, analytics will probably be one of those largest capacity use cases that will exist in almost all enterprises. Think about all these new applications that are coming out, all these sources of data that are coming out, IoT, autonomous vehicles, sensor data that Mike just talked about. All of that is being collected and analyzed. A lot of it is actually being collected, pre-processed, 95% gets thrown away, and then lands up in some location. Even that 5% that lands up or 10% that lands up will turn out to be massive quantities. And imagine when this collections start happening. We are already in discussions with major auto manufacturers talking about their data lake strategy and how Ceph can be a good fit for that. In fact, we even have customers that have already started deploying their SES clusters for their analytics use cases and IoT use cases. So how does it work? Ceph exposes various protocols, CephFS, S3, S3A. S3A is a variant of S3, which is tied mostly to Hadoop. If you have a workload which supports any one of these three, you can deploy Ceph as your storage repository for those workloads. In some cases, through CephFS or through S3A, you can actually run your MapReduce or your Spark job against the data residing in Ceph. In certain cases, that data lake think of the data lake as an archive solution, which the NoSQL database might have to pull it out to do some work against it. So it depends on how your architecture is. But this is where you pretty much need to understand your data pipeline and architect it that way. Spark also sometimes can exceed the requirements of what Ceph can offer, so it becomes a tiered type of a deployment for Spark, but not in all cases. I'll give you an example of a particular customer. This customer had 3 different divisions and each of those 3 were running different versions of Hadoop and Spark. Spark in Hadoop. They had 2 petabytes of usable data, and HDFS, they had deployed HDFS. 2 petabytes of data means 6 petabytes footprint in HDFS in Hadoop. They had exactly the same copy of the data in their second department and the same copy in their third department. Total footprint of that data was 18 petabytes. And they were growing at a decent rate. When they forecasted their capacity growth because some new applications were coming on board, they realized that their data the growth was gonna explode. And few years down the line, they were looking at a 100 petabyte footprint for just storing that Hadoop data because of the multiple copies that they were creating. That was problem number 1. Problem number 2 was they needed to be able to get more agile because test teams wanted time onto the main cluster, on the production cluster, because there was only, each department had 1 copy of the data. Test team would have to take over the cluster, change the cluster to a different version, and then migrate it back to the older version during those downtimes. They couldn't afford the downtime for production environment at that point. So eventually, this is the architecture they created. Instead of that 2 petabyte, they had already grown to 5, 6 petabytes when they deployed Ceph. They deployed a 10 petabyte Ceph cluster, started with just those 3 Spark deployments in production, after, of course, doing some test and dev. They basically create, for those 3 departments. The 10 petabyte was about an 18 petabyte actual footprint. So first thing it did was control their growth. The incoming stream of IoT that they had, it would basically get pre-processed by Kafka and written to the Ceph data lake. Eventually, they started adding other applications to the same data lake. Logstash was probably one of the first ones that they did. Then they went ahead and added other enterprise apps to the same data lake because it became such a successful project. And all this happened within a couple of years. And they deployed Elastic to be able to do enterprise-wide discovery around that also. Eventually, what they got was a consolidated, lower footprint analytics pipeline, I guess. Agility, because now anybody could harness the main data and run a Spark job against it, even if it was for a test use case. Better predictive capability because they were able to combine data from other sources which didn't even occur to them when they first embarked on the project. And cost reduction because of the lower footprint. And lower cost of growth. This turned out to be one of the successful use cases that they had. There are other customers running similar types of things. NCHC is talking about their AI cloud, which they built on OpenStack and used Elasticsearch and a bunch of other things tomorrow afternoon. I'd recommend you go check out that customer testimonial. How much time do I have? Questions, comments about the previous slide? Okay. So, file sync and services solution. This is another very interesting use case. Lines of businesses are looking for Dropbox-like solutions. And this is the answer to that. There was a hospital chain out of Germany that realized that their doctors were asking for Dropbox-like, and those guys had already started researching use of public cloud solution. When they realized that their researchers and doctors needed that, they went ahead and deployed a C-file-based file sync and share solution. what they ended up doing was deployed a couple of 100 terabyte of internal Dropbox-like solution for their researchers. Over time, that customer became so successful that they added maybe 3 or 4 different use cases on top of that. Started with 200 terabyte, now they are a multi-petabyte storage solution. It's a hospital chain based out of Germany. So we have certified a number of file gateways, I guess, gateways, and each offer their own advantages and disadvantages. 2 of them are open source solutions. One of them is Micro Focus Filer, our old parent company. And then there's also Storage Made Easy, which is an enterprise file services solution. There is one more on the roadmap, which is Cetera, which is not certified today, but it is on the roadmap. A compliant archive solution. There is a small software firm which offers a compliant solution for customers. They have certified their product with various business applications. Take, for example, NICE video recording. NICE video recording is a very common application used in financial industry for traders to make phone calls. Whenever traders use any kind of communication, it gets recorded because of US SEC regulations. So that's a very common application that gets deployed in those financial institutions. Or whenever you call some company, especially those in the regulated industry, that phone call is probably getting recorded. There's usually a message saying your phone call may be recorded for training purposes. It's not for training purposes. It's for legal protection against you suing them. That's the reality of these industries. So what Eternity has done is they have certified against a bunch of these business applications, and we have certified with Eternity and created a full end-to-end compliant stack. This compliant stack basically allows customers to deploy a bunch of these business applications which might be which may require compliant storage underneath. And by compliant storage, I mean which offers audit capabilities, storage that offers audit capabilities, storage that has worm capabilities, write once, read multiple times. So we've come out with the full stack with Eternity, which offers that capability. We have customers that are, the previous hospital chain that I talked about in the last slide, one of the use cases that they have added is a medical business application that they have deployed with SUSE Enterprise Storage. Now, this particular hospital, they've actually grown and have, like, I think, four use cases: file sync and share, compliant storage, and they're looking at adding other, and backup is one of the use cases, and I forget the 4th one. But it's one of those where they were successful once with one single use case, and over time they've grown to add multiple and many more use cases against the same storage solution. That's a very common model that we see in the industry. Other use cases that are available with Eternity are file and email archiving with OpenText, voice recordings I mentioned, multiple healthcare applications like AGFA and GE, records retention for Ceph, for example, etc. The list continues. They have over 100 certified applications.
Where does it sit? I'm sorry. Where does it sit, the Eternity?
So Eternity would sit on a separate server in front of SUSE Enterprise Storage. It basically becomes a gateway to. So in the hospital's case, what they've done is they have a multiple petabytes, out of which just 400 terabytes is reserved to be compliant underneath that gateway. The rest go direct, and that is considered non-compliant. For example, their backup application is writing directly to SES. Their file sync and service storage is writing directly to SES. But whatever comes through Eternity is considered compliant. The application that requires compliant storage sits on top. Questions, comments about this, or previous anything? OK. Archival solution with Point Storage Manager. Point Storage Manager is a classical archival solution which basically deletes data from primary and puts it onto a secondary storage and creates a virtualization layer, I guess, a stub-based virtualization layer. This came out of this certification came out of a specific client who was looking to deploy SES, and they already had Point in their environment. What Point does is it basically monitors storage when any file in the storage that is being monitored gets older than a certain number of days. It gets deleted from there, and a stub gets put over there. The data actually gets migrated over to a second-tier storage. When somebody tries to recover that file, it'll basically get hit. The application or the user will try to recover that file. It'll get redirected to secondary storage, and data will be reverted back from there. Very simple stub and replace type of a storage archival solution. This has been successfully deployed in at least a few clients that I know of, and they're successfully being able to reduce the load on their expensive tier 1 storage. Very commonly deployed with some NetApp and EMC storage solutions. This pretty much covers some of the solutions that we wanted to talk about. The point being is that identify a specific use case where you think SUSE Enterprise Storage might be successful for your environment. Think backup. Think the use case where you can start getting comfortable over time, and soon you'll realize that once you're comfortable with one use case, you'll be able to add more and more to that particular use case. What SES can do for you is help you take you into that software-defined data center. It can be the bridge to navigate you into a fully software-defined data center. Once you deploy SES, or once you deploy software-defined storage, you'll realize that the next step, application migration to a fully software-defined data center, that can become your secondary project, with storage being the bridge. Please speak to your customers or your peers, attend some sessions, and have a great day. Questions, comments? All right, folks, thank you so much. Have a good afternoon and a good rest of the day. Thank you.